Welcome to the part 3 of today's session. In this module, we'll be discussing about force between two parallel currents. Let us consider two infinitely long straight wires carrying currents I1 and I2 in the same direction. They are separated by a distance A. So, considering the first wire alone, at a distance A from the wire with current I1, the magnetic field due to the wire is given by B1 is equivalent to mu 0 I1 by 2 pi A. We had already discussed the equation B is equivalent to mu 0 I by 2 pi D due to an infinitely long straight conductor carrying current. Hence, the force on the second wire F2 due to the magnetic field produced by the first wire is given by I into dl cross B. That was the equation for magnetic force. So here F2 is equivalent to I2 into L cross B1. We have considered only a section L of this infinitely long straight conductor. Here L and B1 will be always perpendicular to each other, so that L cross B1 can be simply written as LB1. So force F2 is given by I2 into LB1. Substituting for B1 from the above equation, we get F2 is equivalent to I2L into mu 0 I1 by 2 pi A, which can be written as mu 0 by 2 pi I1 I2 into L by A. The direction of force can be got from Fleming's left-hand rule. We have studied Fleming's left-hand rule in class 10, according to which if forefinger represents the magnetic field and middle finger represents the direction of current, then the thumb of your left hand will give you the direction of magnetic force. So, in the case of two parallel conductors carrying current, the second wire experiences a force F2 due to the first wire. Similarly, the first wire will experience a force due to the current passing through the second wire. So the force on the first wire due to the second wire is given by mu 0 I1 I2 by 2 pi A into L. So we have seen that force per unit length will be given by F by L, which is mu 0 I1 I2 by 2 pi R, where R is the separation distance between the wires. Though the magnitude of force on conductor 1 and conductor 2 are same in magnitude, the direction of force will be as shown in the figure. That is, if like currents or currents are passing in the same direction through both of these conductors, then there will be a net attractive force between the wires. In a similar way, we can also prove that if the currents are in opposite directions or if the currents are anti-parallel, then there will be a force of repulsion between these wires. So we have seen that the force is attractive if the currents are in the same direction, and the force is repulsive if the currents are in opposite directions. And magnitude of force is given by mu 0 by 2 pi I1 I2 by d into L. Hope you have understood about the force between two parallel conductors carrying currents. Thank you, dear students.